What's going on, everybody? Welcome back to my YouTube channel. Look at these nice and beautiful question on the board that we're going to be solving. And the question says, find the value of 2x minus 1 all over x minus 2, for which 45 to the x is equal to 75. Well, our first step will be for us to break down this 45. 45 can be broken down into 3 times 3 times 5. And this is raised to the x, so we're going to be raising this to the x. Equal to, now 75 can be broken down into 3 times 5 times 5. So this simplifies into 3 times 3 is 3 squared times 5, and this is raised to the x, equal to, now this is 3. 5 times 5 is 5 squared, so we're going to multiply this by 5 squared. Our next step will be for us to apply the law of indices, which says, for example, when I have a to the m, and this is raised to the n, this is equal to a to the m times n. That means the powers multiply. And this power here affects the 3 squared, and it also affects the 5. So we have 3 to the, remember, powers multiply, 2 times x is 2x times 5 to the x. So 5 to the x. And this is equal to 3 times 5 squared. Our next step will be for us to divide both sides by 3 in order to get rid of this 3 from the right hand side. So we divide both sides by 3. We have 3 to the 2x times 5 to the x. I'm going to be dividing this by 3, equal to, now on the right hand side, I have 3 times 5 squared. I'm also going to be dividing it by 3. Our next step will be for us to apply another law of indices, which says, for example, when I have a to the m dividing by a to the n, this is equal to a to the m minus n. So the powers subtract. So let's subtract the power. The power here is 1. So this is 3 to the 2x divided by 3 to the 1. So this becomes, according to the law of indices, 3 to the 2x minus 1. And this is multiplying 5 to the x, equal to, now the 3 here can cancel off this 3, leaving behind 5 squared. Our next step will be for us to get rid of this 5 from the left hand side so that we only have it on the right hand side. And in order to do that, we're going to be dividing both sides by 5 to the x. So I'll divide the left hand side by 5 to the x. I'll also divide the right hand side by 5 to the x. Now notice that 5 to the x can cancel out 5 to the x, leaving behind 3 to the 2x minus 1, equal to, now let's apply this law of indices to what we have here. So this becomes 5 to the, let's subtract the powers, 2 minus x. Our next step will be for us to take the log of both sides. I'm not just going to be taking just any log, but I'll be taking the log base 3 of both sides. So I'll take the log of 3 to the 2x minus 1 base 3. Remember, I'm taking the log base 3 of both sides, equal to, I'll do the same thing here, log of 5 to the 2 minus x base 3. Our next step will be for us to apply the law of logarithm, and we're going to be doing that on the next slide. Let's continue. So the law of logarithm we're going to be applying is, for example, when I have log a to the n, this is equal to n log a. So let's apply this to what we have here. So this is 2 to the x minus 1 times log 3 base 3. And this is equal to, we'll do the same thing here. So this becomes 2 minus x times log 5 base 3. Our next step will be for us to apply yet another law of logarithm, which says, for example, when I have log a to base a, as long as the number and the base are equal, this is equal to 1. And this is what is happening here. So this expression gives 1. So 1 times 2x minus 1 is 2x minus 1. And this is equal to 2 minus x times log 5 base 3. Our next step will be for us to divide both sides by 2 minus x. So I'll divide the left-hand side by 2 minus x. I'll also divide the right-hand side by 2 minus x. Now notice that 2 minus x cancels out, leaving behind 2 to the x minus 1 all over 2 minus x to be equal to log 5 base 3. Remember, this cancels out from here. So this is what we have here. But a question requires us to find 2x minus 1 all over x minus 2. This is actually different from this. So how can we make this to resemble this? Well, we can do that by multiplying the numerator and denominator of the left-hand side by negative 1. So, negative 1 multiplied by 2 to the x minus 1. We do that to the denominator as well. Negative 1 times 2 minus x. And this is equal to log 5 base 3. So this becomes negative 1 times 2 to the x minus 1 divide by, now watch, negative 1 times 2 is negative 2, and negative 1 times negative x is plus x. So this is equal to log 5 base 3. Now we can actually rearrange this to fit in like this. So we have negative 1 times 2x minus 1 all over. Now we can come with the x first. So x minus 2 to be equal to log 5 base 3. Well, our next step will be for us to get rid of this negative 1. And we can actually do that simply multiplying both sides by negative 1. Let's do that on the next slide. So multiplying both sides by negative 1, I have negative 1 times what I have here, then negative 1 times log 5 base 3. So when negative 1 multiplies what I have here, the negative cancels out, leaving behind 2 to the x minus 1 all over x minus 2 to be equal to negative 1 log 5 base 3. Well, you can say this is your final answer, but if you are not satisfied with negative 1 here, you can go ahead and apply this law of logarithm, which says when I have n log a, this can be written as log a to the n. So let's write this in this form. So we have 2x minus 1 all over x minus 2. This is equal to log 5 base 3. Now, writing this in this form, the negative 1 comes here. And you know a negative power means an inverse. So this becomes 2x minus 1 all over x minus 2 to be equal to log. So this is an inverse of 5, which is 1 all over 5, and now base 3. And this becomes our final answer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.